When we first begin designing and analyzing electronic systems, it's really easier to sort of break those systems down into three generic categories, and that's going to be inputs, processing, and outputs. The reason for this is because this is the way you've been taught to think mathematically up until this point, and so it's easy to transition from that style of thinking into an electronic style of thinking. So here we have a problem where we have 2 plus 2. So the inputs to this system are the numerical values 2 and 2. And the process that we're going to perform is addition. So 2 plus 2, obviously the output would then be 4. Now we can change the inputs, we can change their value, so we can change them to say 5 plus 2, and then of course the output is also going to change to 7. Now notice in this case we didn't change the process at all, we just changed the inputs. However, we could leave the inputs the same and then also change the process. So if we change it from addition to subtraction, we would now have a different output because we changed the operation. And so if you can sort of think in these kinds of terms, it makes it very easy to really start to learn how electronic systems work because we can break everything down in this way. The processing part we'll take a look at in upcoming discussions. We'll spend a lot of time looking at logical processes, combinational processes, and even sequential processes. So for now, what I want to focus on is the idea of an input. So we're talking about electronic systems. Those inputs can come from users. You could type something on a keyboard, you could say something and it's a voice-activated system, but typically what we have is some kind of sensors. So we have a sensor mounted to a system or to a person, and then that sensor is going to output some kind of signal. Now it's this signal or waveform that we're most interested in because that can be divided into two major categories. The first one is going to be a continuous analog signal. The second one is a discrete digital signal. Now, as you may have guessed by the name of the course, we're primarily going to focus on the idea of the discrete digital signals. Digital signals are often referred to as waveforms, and when we're examining digital waveforms, we can usually break them down further into three categories, and that is a periodic waveform, where there's a consistent pattern to the waveform as it comes in. We can look at an aperiodic waveform, where there isn't really a pattern to the way the data is coming in or the signal is coming in. We also have a pulse waveform, where the signal seems to almost be static at some point, where it's not changing hardly at all, and then all of a sudden there's a little blip in it, there's a little dynamic change, and then it goes back to its regular resting state. Something to include in your notes at this point is that these definitions for periodic and aperiodic and pulse are descriptive of these digital waveforms. They're describing its behavior. They're not providing us a numerical answer. They're not providing us some kind of anatomy definition. It's really just describing the behavior. We can look at the waveform, kind of see what it's doing, watch what it's doing, and then sort of describe that. Does the pattern repeat itself? Does the pattern never repeat itself? Does the pattern seem pretty consistent except every now and then it changes? It's just a description of the behavior of our digital signal.